In this video, we'll introduce the 5 basic inference rules. Our first one is modus ponens. Modus ponens says that if you have a conditional and the antecedent of that conditional, then you can infer the consequent of that conditional. So let's look at a concrete case. Say that we're given the premises if P then Q and P. We have the conditional and we have the consequent of that conditional, and say we are asked to prove that Q follows from the premises. Well, this is just one application of modus ponens. We can put Q on line 3 and we can cite lines 1 and 2, and we can say that we can infer Q because we know that modus ponens is a valid argument form, and because it's a valid argument form, it is a truth-preserving rule, as in if the premises are true and we infer Q on the basis of modus ponens, we know that the conclusion would also have to be true. Let's look at a slightly more complicated looking version of modus ponens. Okay, here's another one. So again, we have a conditional on a line. Recall that this is the main operator. So statement number 1, premise 1, line 1, that is a conditional statement. The statement on line 2 is the antecedent of the conditional on line 1. That means we have a conditional and we have the antecedent of a conditional. So we can infer, put on a new line, the consequent of that conditional x, and we can justify our doing that by citing lines 1 and 2 and the rule modus ponens. And so we have proven, because we know that MP is a valid inference, we've proven that X follows from the premises P and Q. Now, the important thing to note here is that we didn't have to use atomic statements, we just needed the antecedent to be the same as the line here. So this just has to be the antecedent. So here's another example. There are no tildes or anything in the schematic version of modus ponens over here in blue, but that doesn't mean anything. All we care about is that on line 2 here, we have the exact same statement that is the antecedent of the conditional. So that's the only element of the pattern that we're looking for. Okay, let's look at this one a little bit longer. So first of all, notice how many different atomic statements there are. 4. This would be a no fun truth table to do, so I'm glad we're doing proofs. See if you can, before we move on, pause the video and take a guess at how you would prove that S follows from the 4 premises you're given using our modus ponens rule. And hint, it'll take more than one step. Okay, let's do it. So, modus ponens says if you have a conditional and you have the antecedent of that conditional, you can infer the consequent. So we do have a conditional on line 1, and we have the antecedent of the conditional on line 1 here on line 4, which means we can infer the consequent. And we will cite lines 1 and 4 and the rule modus ponens to justify doing that. Now, on line 5, we have the the antecedent of the conditional on line 2. That means we can use modus ponens to put R on a new line, and we'll justify doing that by citing line 2, where the conditional is, and line 5, where that antecedent was, and the rule modus ponens. Now we have R on a line, which happens to be the antecedent of the conditional on line 3, which means we can infer S by 3, 6, modus ponens. And now that we have the conclusion on a line, the proof is complete. So the only things that you have to do to have an entirely correct proof is get the conclusion on a line using inference rules correctly. Those are the only requirements. Okay, let's look at our next rule. The next rule is called modus tollens. And we'll abbreviate that MT. So what modus tollens says is that if you have a conditional and you have the negation of the consequent of that conditional, then you can put on a new line the negation of the antecedent of that conditional. So here's an example of a proof where we can use modus tollens. On line 1 we have a conditional statement, and on line 2 we have the negation of the consequent of the conditional on line 1. Now notice how this form is the same as the one in the schematic. The tildes are different, but what we have is a conditional, and what we have is the negation of the consequent of the conditional. Q is the negation of not Q. So importantly, by negation we mean either adding or removing a tilde. So not Q is the negation of Q, Q is the negation of not Q. So, since we have the conditions to use modus tollens, we can put the negation of the antecedent, which would be P, on a line, and we'll justify that using 1, 2, MT. Now, we said that negating means either adding or removing a tilde. We could equally as well have inferred not P. We could have added a tilde instead of removing a tilde. And we would use the same lines and the same rule. All that the rule says is if you have a conditional and you have the negation of the consequent, you can infer the negation of the antecedent. And both lines 3 and 4 here are equally good negations of the antecedent. And that makes sense, right? We're pretty familiar with a double negative sort of canceling out. However, if you had done this, you had inferred not P for some reason, then you haven't actually completed the proof, assuming that you didn't do this, you just did not P. Why? Because the last line isn't identical to the conclusion you were asked to prove. You have only completed a proof if you get the conclusion on the last line and you used all the rules correctly. So we will stick with this one. And that's a complete proof. Okay, here's a slightly more difficult proof. This proof requires both modus ponens and modus tollens. So I recommend pausing right now and trying to complete the proof on your own, just to see how you go about it and where you get stuck before you continue watching it. Okay, so there are two ways we can approach this, and one is to just do anything we see. By that I mean I see that I have a conditional here, so I'm thinking either modus ponens or tollens could apply to either of these, and so I'm looking, what else do I have here? I have the antecedent of the conditional on line 1 and 2. So I see that the only rule I can apply is modus ponens. And then I can get started and start inferring things. The other approach I can take is look at what I want. I want not Q. Not Q is up here in this conditional. It's part of another conditional. And so I'm wondering, how could I get this whole conditional on its own line? If I could somehow, using our rules, get this conditional on its own line, maybe that's what I'll end up working with to get not Q. And indeed, what I want, not Q, is the negation of an antecedent. And modus tollens is a rule that lets me get a negation of an antecedent. I would need not R to do that. If I had these two things, then I could get not Q. So I have this sort of plan. Get this, then use modus tollens. So now I have two things I'm working towards. Can I get this? Can I get this? Well, what does it take to put the consequent of a conditional on its own line? Well, that's something that modus ponens lets you do if you have the antecedent of that conditional, and we do. And the other thing we want is not R, which is also the consequent of a conditional, and we have the antecedent of that conditional as well. So I have this bigger plan in my head. I'm going to use modus ponens twice, once to get once to get this, once to get this, and then I will use modus tollens after I have those on their own line. So that's kind of a big picture thing, but let's just go through it step by step. So we said we have the antecedent of both conditionals on lines 1 and 2, so we can just immediately use modus ponens twice. First, we will infer the consequent of the conditional on line 1, and we'll cite lines 1 and 3, modus ponens. And we'll do the same thing with lines 2 and 3 to get not R. We'll cite lines 2, 3, modus ponens. So one thing you might notice is that we use line 2 twice. There's no prohibition on using lines more than once. You don't have to use every line in the proof. You can use lines multiple times. The only rule is that you get the conclusion on its own line and you use rules correctly, and if the rule doesn't bar doing something, you can do it. Okay, so we used 2 applications of modus ponens. Now we have a conditional, and we have the negation of the consequent of that conditional. So we can use modus tollens to get the negation of the antecedent, which is what we're trying to get. So that works out well. And we'll cite lines 4 and 5, modus tollens. Proof complete.